Okay, for geometry lesson 7.3, we are still working on triangle similarity, and something that's new is called angle angle similarity. And I hope you remember that when we were trying to prove triangles are perfectly congruent, there was no such thing as angle angle. You couldn't have two of the angles because what that meant is one could be the same as the other one. The other one would be the same angle measures but bigger. So these angles, or these triangles were definitely not congruent. But you can prove angle angle in similarity, because congruence means same size and shape and everything, but similarity means you could be on a scale factor. As long as you have two of the angles congruent, you can prove that the triangles are not congruent but similar based on this angle angle similarity. So let's take a look at number 1 on 7.3. You have two parallel lines, and if you remember the rules about parallel lines cut by a transversal, this makes some alternate interior angles here congruent and some alternate interior angles here congruent with this transversal. And actually, you should remember vertical angles as well. So we definitely have all three angles congruent. All we need is two to have the angle angle similarity. So this one is yes. These two are similar. Okay, it says write a similarity statement if so. So the similarity statement would just be ABE is similar to, I went from the 2 to 1 to 3, so I'm going to go from the 2 to 1 to 3. So DCE. DCE. Okay, number 2, I see an angle on each and I see a side length on each, but that's it. And actually, I can already tell just by looking at them that these are not similar. So these are not similar because we don't have angle angle similarity, we don't have side angle side, we don't have angle side angle, we don't have any of those proving triangles congruent or similar. Okay, in this one we have two parallel lines and we have one angle, but if you think about it, NPO, this angle up here, is the same in both angle NPO as it is in NML because they share this angle up top. So the angle up here is definitely congruent to itself reflexive. So we do have this one angle. The parallel lines do something interesting. So the parallel lines, this is another new thing. If you have parallel lines, then you have, and on the same triangle that meet in the same point, you have a very interesting thing that forms congruent angles in their corners. This is like corresponding. If you remember that from when you have two parallel lines, you have corresponding angles. And then that would be the same thing down here as well. So this one, these two would definitely be similar because you've got the reflexive angle up here plus the corresponding angles from the parallel lines. Okay, so this is yes, and I would say maybe LNM is similar to ONP. Okay, down to number 4. I see these two vertical angles and I see these two side lengths, but these sides are not parallel, so we can't assume anything else. So this one is going to be no. Okay, number 5. This one is interesting too. So first check the side lengths, 28 and 14. So this is twice this. So 28, so the scale factor is 2 to 14, and then once again the scale factor on the side is 10 to the side is 5, so it's 2. So the scale factor is correct. You know that the scale factor is similar on this third one because if they are on the same line, it's going to be the same slope. So you have all three side lengths that are similar. It's on a scale factor of 2 to 1. So if all three side lengths are on the same scale factor, that is a yes. So I would maybe say TVU is similar to UXW. Okay, number 6, Side lengths again. These are doubled. 26 is double 13. 30 is double 15. So once again, a scale factor of 2 for all three side lengths. If all three side lengths have the same ratio, it is yes. So I'm going to say MLN is similar to QOP. Okay, let's go down here, and basically what you need to know is if the right side 2/6 is similar to the left side 3/7, then it is yes, this would be similar. And I'm not going to make you guys use the postulates or theorems anymore. You just need to know that the side lengths need to be on the same scale factor. So 2/6, is that equal to 3/7? And you can do the little cross multiply up trick. 6 times 3 is 18. 7 times 2 is only 14. So this one is no. All right, number 2, 12 to 30 to 36. I'm going to write those all down. 12 to 30 to 36. Are those on the same scale factor as, I went in size smallest to biggest, 8, 20, and 24. 8, 20, and 24. So I would start by maybe simplifying these. 12, 30, and 36 each divide by 6, which would make this one 2, 5, and 6. Each of these divide by 4, which would make them 2, 5, and 6. 2, 5, and 6 is the same scale factor as 2, 5, and 6, so this one is yes. Okay, 50 to 25 and 40 to 20. Let's see. I have no idea what that is. 50 times 20 is 1,000, right? Let's see what 40 times 25 is. 1,000. So this is a yes. Or you could simplify them and see if you get the same answer. That's double, that's double. So yeah, that would have been a lot quicker. Okay, you have to have angle similarity, at least 2 of them. And we have 48, 76, and I don't know. So I'm going to subtract from 180. So 180 minus 63 minus 76 is 41. Wait. Did I just do this little one? I'm sorry, I meant to do this big one. Not that it matters. 180 minus 76 minus 48 is 56. Okay, so then let's look at the other ones. If we have 76 and we have 63, it's probably not going to work out, but let's double check. So 180 minus 63 minus 76 is 41 up here. So we have one angle that's the same, but neither 56 or 48 is here. So these are no. You have to have at least 2 angles similar or same to be angle similarity. Okay, let's move on and look at this word problem. It says a 1.4 meter tall child, so since we're measuring in metric units, I guess, apparently, is standing next to a flagpole. The child's shadow, okay, I'm already going to have to draw this out. So a 1.5, let's say here's my measurement, 1.4, meters tall child is standing next to a flagpole. Okay, so the child's shadow, so if I measure the child's shadow, here's the shadow, is 1.2 meters long. And at the same time, the shadow of the flagpole is 7.5 meters. How tall is the flagpole? So shadows that are cast are similar. I would go ahead and see that this is actually a triangle, 2 triangles we're talking about, And so we're trying to figure out how tall the flagpole is. So I'm going to put an X here. So if this needs to be, if they're similar, they would be on the same scale factor. So I would just set it up exactly like this. 1.4 over 1.2 equals X over 7.5. So I've got 1.4 over 1.2 equals X over 7.5. And now you could do this differently. You could do 1.4 over X equals 1.2 over 7.5. As long as you're consistent in the way you go and the way you set them up, it doesn't matter. Either way is going to be fine. So I'm going to multiply the bat and divide by the ball. So 1.4 times 7.5 is 10.5 divided by 1.2. The flagpole is 8.75 meters tall. Okay, let's look at the back page. So number 10 says explain why these triangles are similar. And what I want you to know is we're not going to actually break this one all apart because we've got a lot of these to do that we're going to practice. But if they are on the same scale factor, if 16 is equal to X because one of the other sides is equal to the other side and we can set up a ratio, we can figure this out. So I'm going to kind of skip around here. I'm going to go down to number 12. We don't need to look at all of these just because we've already looked at several. So this is this word problem. So let me try to figure this out with you. A stick that is 2 meters long is placed vertically at point B. So here's your stick. Okay. The top of the stick is in line with the top of the tree as seen from point A, which is 3 meters from the stick. So here's your 3 meters from the stick. And it is 30 meters from the tree. So there's a 30 down here. How tall is the tree? So once again, we are just going to set these up as a ratio. So 3 per 2 would be equal to 30 per X. That's just one way to set it up. There are multiple different ways you can set this up. I could have flip-flopped them. I could have done 3 over 30 equals 2 over X. It just doesn't matter. You're going to get the same answer. So the bat is 60 divided by 3. That is going to be 20. So how tall is the tree? The tree is 20. We're talking about meters tall. Okay. We've already done a few of these shadow questions, so we're going to move on to number 14. Identify the similar triangles in each figure. So this one is an interesting one too. There are actually 3 triangles in this picture. There's this one on the kind of top, there's this one kind of on the bottom, and then there's the big one that encompasses both triangles. So what I want you to look at is the 2 right angles. One of these right angles is on the large triangle ABC, and the other right angle is this one on the, I'm going to say right now that I've twisted my paper around, and it would be BDA. So those are the 2 similar ones that we have. So the similar triangles are ABC, and it is similar to BDA. And the reason we know that is because of the right angle in each one. Okay, we're going to kind of start skipping because I think this all is probably going to start making sense. Again, you have a right angle here. And then if I twist my paper, you can see that I have a right angle with this large triangle here. Which actually would also be this smaller one because all I'm looking at really is this right angle, and this right angle is in both this smaller one and this larger one on both. So really it doesn't matter which one we write down. So I mean actually we could write all 3. So let's write all 3. So VWU is similar to UVT, and it's also similar to YVX. Okay, I am going to move down to the last part of what we're doing today. It's some algebra. It says explain why the triangles are similar, but I'm just going to say assume they are similar. And then in order to assume they're similar, we're going to need to find what x is. So let's just practice finding the value of x and working on your algebra skills on these. So if they are similar, this is the short side, similar to this short side. So I'm going to put 21 over 2x. So 21 over 2x, and that is going to be equal to the hypotenuse of the small side, which is 40. So I'm going to put that on the bottom because that's where my small one is. And then the long one is x plus 4. Sorry, 11x plus 4. You can cross multiply 21 times 40, which is 840. And then when you cross multiply the other side, you're going to have to distribute. So 2x times 11x is 22. Be careful here, x squared. And then plus 8x. Okay, this is going to be some fun math that you probably haven't done for a while. I'm actually going to subtract 840, and I want you to remember why. Once I have it set to 0, I have 22x squared plus 8x minus 840, and I could actually go on now and factor. So if I factored something out of 22, 8, and 840, I think it's only 2. So I'm going to pull out a 2, and it's going to leave 11x squared plus 4x minus 420, if I did that right. And then I'm going to have to actually continue factoring. Don't know if you guys remember how to factor, but this would definitely be 11x and x. 11 times what is 420? We're going to review that. I just picked a really hard one for us to try, and I'm not going to give you any that are on your test or anything like this. I just wanted to try to practice factoring. But actually, I probably should have done the whole method where you multiply these and find what you can add to get 4 and what you can multiply to get 420 after this. So I've kind of set this up as wrong, but this is how you would keep doing it. And what you would do is you would get the value of x, and one of them would be a false answer, and the other one would be an answer that would be able to be right. So I will definitely not make you do that. I'm sorry about that one. Let's try 13. So 13 is 6 over x equals x minus 1 over 2x plus 4. I think this is going to happen again, but let's just make sure at least you could get it set up right. 6 over x equals x minus 1 over 2x plus 4. Oh man, you guys, this is going to happen again. Okay, that's okay. Let's get as far as we can, and then I'm not going to make you guys factor yet. We will definitely review this before Algebra 2. So 6 times the quantity 2x plus 4 would be 12x plus 24. And that equals x times x, which is x squared minus x. Yep, so you would minus x squared, and you would have all kinds of fun stuff. You would add x, so it would be plus 13x plus 24 equals 0. We would factor out our negative. I'm definitely going to stop here. But we will definitely review all of this before Algebra 2. So anyway, this is what you would do. Looking forward to it.